Hello everyone, this is Algebra Made Simple. I'm your host Chris Morris. Thank you for coming on the program today. Let's just go ahead and get into the topic of what will be several videos. It's one of the most requested topics from algebra students over my 12 years of experience doing this day in and day out. I love me some algebra. I've been doing it and the kids are always bringing this up. Yesterday at this other part-time job I work at, I have some students I work with and they flat out told me, Chris, we need you to do a bunch of videos on factoring. Will you please do me a bunch of videos on factoring? So I'm just going to not waste time and get straight into it. Factoring is probably one of the most comprehensive topics that you have to cover, depending on what school setting you're in. If you're in the public school setting or depending on, private school setting, it could go a little quicker or faster. It just depends, but it can take weeks for kids to get a handle on this because there's so many different things and scenarios that you have to go through. So today we're going to do video 1, which is talking about the most basic form of factoring, which is the greatest common factor method. The greatest common factor method. I always tell students the very first thing you should always look for when you're asked to factor a polynomial in algebra is, does it have a GCF? That stands for, of course, greatest common factor. So before we go ahead and look at the polynomials, I want to go ahead and start with just asking the question, well, what in the world is a greatest common factor? I don't even know what that is. I don't even know where to start. I thought this was algebra made simple. Let's make it simple. So let's take, we have this first polynomial that hopefully you can see here. Let me change the color so you can see that. We have this first polynomial here. We're not going to even start that before we begin the discussion on greatest common factor. I mean, what in the world is that? So I want to just give you this as an illustration. Since the very first problem we're going to do in a minute have the coefficients 16 and 4, I'm going to do a comparison of these two numbers, okay? You with me on that? So we'll just, I don't know, we'll put, this is my horrible chicken scratch, so I'll probably come up with better methods as I do more videos, so forgive me, but this is what I'm going to do. Those are supposed to be colons, okay? Those are colons, all right? So what I want to do is think about, well, what is a factor? A factor are numbers times other numbers that equal the initial number you're talking about. What are you talking about, Chris? Well, let's take 16, for example. What times what can you think of that equals 16? Somebody's going to go, well, what about 1 times 16? Technically, that's true. 1 times 16 equals 16. So 1 and 16 are factors. You get it? Also, what else goes to 16? Those aren't the only two numbers that multiply to 16. How about 4 times 4, right? 4 times 4 equals 16. Now, since it's the same number twice, 4 times 4, there's not really any need to repeat 4 2 times here, right? What about 2 times 8? Almost forgot about that one, right? So what you want to do is just spend some time either writing out the factors or you can think them through in your head. It depends on how well you know your multiplication facts. People who know them very well can probably think of it in their minds. Those of y'all who need to go over that a little bit more, I suggest listing them out. And then you go down to the other number. You got 4. And well, what are the factors of 4? Well, 1 times 4. You might as well start with the obvious, right? Keeping it simple, you might as well start with the obvious. And then, of course, you got 2 times 2. Since 2 times 2 is the same number twice, I just list it once, right? And you simply just need to take a good look. Okay, what is the biggest number in that list, in both of those lists, that appears in each one? Well, looks like 4 goes into 16, and 4 also goes into 4. You can't pick 16 because there's no 16 down here in the 4 list, right? You can't pick 8. It's a big number, but it's not in common. So you're looking for the greatest factor that also is in common to both groups, if that makes sense. So we did that long list to kind of give you an idea of what we're looking for here when it comes to how to factor by the greatest common factor. So if we're looking at number 1, number 1 would be up here. We're going to already conclude that 4 is the greatest common factor, if that makes some sense to you guys, all right? So I'm going to see if I can just kind of back out of this a little bit and save some time, and then we'll go ahead and get straight into the first example. Oh, it's working, yay, 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 yay. Okay, so let's talk about the polynomial now. Now we're going to start with this one right here, number 1. This is a 2-term polynomial, but before you even worry about how many terms a problem has, which I know some of y'all, if you're in algebra class, they make a big deal about how many terms there are, and you need to, but the step 1 is always what is the GCF? That's the first question you need to ask, or is there a GCF? So I'll give y'all a second. 16p to the 4th plus 4p to the third. What's the greatest thing they have in common? Well, we just did that. We did 16 and 4. We found out that 4 was the greatest factor that they each had in common when we did those lists a second ago. But the other thing you need to keep in mind are these variable components. When you see p to the fourth, I want you to realize that's the same thing as p times p times p times p. In other words, there's 4 p's being multiplied together. When you have p to the third, that's the same thing as 3 p's being multiplied together. It's just shorthand for that. So when you're trying to come up with what's in common in each group, what's in common between 16p to the fourth and what's in common between 4p to the third, you could say they each have 3 p's in common. They each have at most 3 p's. You know, the top one has 4 p's, the other one only has 3 p's. But what do they have in common? The most they have in common is the 3 p's. You with me? So for that reason, we're going to say p to the third is also part of that GCF. Little hint. Anytime you're doing these polynomials with the GCF, you look at those variables, the letters, whichever exponent, 4 and 3 is what we're looking at here, right? Whichever exponent is the smallest, in this case, that would be 3, that ends up being the GCF as well. Okay, so there's a little tip for you to kind of make yourself go a little quicker for those of y'all who appreciate it, all right? So we just found out the GCF between 16p to the fourth and 4p to the third was 4p to the third. Now comes the process where we have to divide each term. So the 16 to the p to the fourth, we have to divide that by our GCF. We have to divide 16p to the fourth by 4p to the third. We have to also take 4p to the third and divide it by 4p to the third. And they go in the parentheses. So if you can do it in your head, that's awesome. But for those who are more visual, it might be helpful to come out to the side. So for this first example, I'm going to show you. I'm going to take the first term, which was 16p to the fourth, right? I'm going to take that, and I'm going to divide that by 4p to the third, right? So there's a couple ways you can look at this, but we'll explore both. So first, we want to start with those coefficients. So the 16 and the 4, right? Well, 16 divided by 4, hopefully you understand that's equal to 4, right? And then I said a second ago, maybe you need to see this. P to the fourth is shorthand for saying 4 p's, right? P to the third is shorthand for saying 3 p's. If I need to go out here to the side and just do it, some people just need the visual, you know, learn what kind of learner you are, right? But that's the same thing as, whoop, sorry guys, I'm trying to draw on this. It's not the easiest thing to do. So you got 4 p's at the top, 3 p's at the bottom. You can cancel out p for p, top to bottom, and you're left with 1 p at the top in the numerator. So I know that when I divide those out, the final answer will be 4p. And I'm going to put 4p in that first spot in the parenthesis, okay? Now, for those who have reviewed the properties of exponents, you know that when you're dividing two like bases, p and p, you can simply subtract their powers. So another way of doing this is to say, okay, well, p to the fourth, 4, take away 3, that equals 1, right? So the answer has to be p to the first power, which we just leave as p. So you can expand it using this method, or you can literally use that property of dividing. It's the quotient property of exponents, okay? So depending on what level, I know we got people that are on all different levels probably watching this video. That's kind of how you have to think about it. So let me delete all this stuff. Hopefully you can rewind it if you missed something, okay? So, but remember, this equaled 4p. 16p to the fourth divided by 4p to the third was 4p. Now, we're going to simply take the next term. That's 4p to the third divided by 4p to the third. Well, guys, that's the same thing divided by the same thing. Anytime you take a number divided by itself, or even a term divided by itself, it always equals 1. It's a positive 1, so I say plus 1, right? 10 divided by 10, it equals 1. A million divided by a million, it's the same thing divided by itself. It equals 1. Therefore, 4p to the third divided by 4p to the third equals 1. And I am done. I have just factored this polynomial into two groups. If it's properly factored, you can multiply it back, but that's how you do it, okay? So just to recap real quickly, I just want to come on screen for a second and talk to the people. Listen, anytime you're asked, I don't care how many terms it has, it can have 3, 4, it can look really complicated. The number one question you need to ask yourself is, does it have a GCF? And what is the GCF? So maybe those are two questions in one. Does it have a GCF? And what is the GCF, right? So we're going to do the same thinking when it comes to this next problem, okay? So pulling that up again. Now we got 2. Now here's a little trick that gets kids that I need to point out. It's happening in both questions 2 and questions 3. Little detail. See the difference here? There's a little detail right there that makes things a little complicated, but not too bad. We're going to keep it simple, right? Algebra made simple. Whenever your first term or what's called the leading coefficient, this big number in front of the letter R is called a coefficient, okay? So when your leading or initial coefficient is negative, you need to go ahead and get into this habit, make your GCF negative. Make your GCF negative, okay? And there's reasons for that we'll explore as we have future videos. But since that says negative 6 R to the 5th, I'm going to find my GCF but write it as a negative. Now, what goes into both negative 6 and negative 6, the greatest thing they have in common? Well, that would be 6. But since I said make it a negative, we're going to say negative 6, right? They're the same thing, so that's pretty easy to see what they have in common. But look what I said earlier. You got R to the 5th, you got R to the 4th. When it comes to the GCF, if the bases are the same like that, you go with the exponent that's smaller. So I know that this true full GCF is not just negative 6, it's negative 6 R to the 4th, okay? Negative 6 R to the 4th. All right, now that we have found the GCF, now we get to do the division part. Now I'm going to do this one a little quicker. Hopefully you can keep up with me. But now we're just going to go one at a time. So first we're taking negative 6 R to the 5th, and we're dividing it by negative 6 R to the 4th. Well, negative 6 divided by negative 6 is 1, right? It's 1. And if you got 5 R's at the top, 4 R's at the bottom, if you cancel those out, you're left with 1 R. The quotient property says take the exponents of 5 and 4 and just subtract them. So that's going to be 1R to the 4th. 1R to the 1st. You could say 1R to the 1st like that, but to be honest with you, most people just assume it's understood that that's to the 1st. You're not going to see that in there. And so that's what that looks like. It's just R, okay? Remember again, this is coming up again. You got the same term, negative 6R to the 4th divided by negative 6R to the 4th. Anytime you got the same thing divided by the same thing, the answer is always 1. It's always positive 1, in fact. So that's why we say plus 1. So we're done. We've just factored the second one. I cannot emphasize this enough. If that leading coefficient is negative, make your GCF negative. It will help you when you get to grouping when you have, when you have 4 terms, okay? Now this last one, a lot of times kids jump the gun a little bit. If you look at number 3 right here, they may have been taught the process for factoring trinomials, which is a little different than the GCF method, but that doesn't make the GCF null and void. You still, no matter what the polynomial is, you need to look and see if there is a GCF and do that first. You must do that. Okay, my kids who are in my traditional classes, they know. They say, I always say, what's on my 1-string guitar? I got 1 string on my guitar. Ding, 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 ding. And the only note it plays is GCF, GCF, look for the GCF, identify the GCF. You have to deal with the GCF before you can do anything. Ding, 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 ding. I play that 1-string guitar note every time we have a polynomial, and they know. I'll just get out and start doing this in class, and a lot of times they're like, oh yeah, GCF, okay? So teachers, whatever weird wacko way you got to say it so it sticks in kids' minds, okay? So here we go. Number 3, you got a negative leading coefficient again. Look at that. So I can already tell my GCF is going to be negative. I'm going to go ahead and put that there. And then you got to start thinking, 28, 8, 36. Goodness, what is the greatest thing they have in common? I know 28, what's that? 7 times 4, but 7 doesn't go into 8. 8 is 8 and 2. Probably 4 is what I'm thinking. I think 4 goes into all of those, all right? If you know your multiplication tables really well, this can be a quicker process. If you don't know it, I suggest going over them. It will really make your life easier with this, okay? Now, it's tempting to be like, oh, look, that has a v squared, that has a v. I see a lot of kids go, okay, then it's negative 4v. Wrongo. This last term on the end, negative 36, has no v. Therefore, it's not in common. When you find the greatest common factor, it has to be in common to all terms. This one has 3 terms, and even though 2 of them have v's, the last one doesn't, we can't include that in our GCF. So we're going to say negative 4 is the GCF. No variable this time. That's okay. Well, what's negative 28 divided by negative 4? I think that's positive 7, right? And since there wasn't a v squared in the GCF or a v, we'll just leave the v squared there. There's nothing to take away there. Negative 8 divided by negative 4 is a positive 2, so we're going to say plus 2, right? And then, there's no v's to take away, so we leave the v that was there. And negative 36 divided by negative 4 is a positive 9, okay? So this has been factored by GCF. For those who are advanced and ready, sometimes these trinomials in the parentheses can continue to be factored. You have to go through the process that you have learned and see. Sometimes they can't be. I don't think this one can be factored. I haven't checked in all honesty, but right now, today's video, the purpose is to show you real clearly how to factor the polynomials by the GCF method. That's step number one. And then you can go on to how many terms does it have, because there's lots of protocols for when that is the case, right? Okay, so let me know what you guys think in the comments with this one. Did you understand how to factor by GCF? Did you understand that when the leading coefficient was negative, you need to be making your GCF negative? Has that been getting you in class? Is it possible that you didn't understand, when you have a base like r to the fifth divided by r to the fourth, you just keep the r and subtract the exponents? That's called the quotient property, all right, of exponents. Maybe that was your cause of confusion. Maybe you like the visuals where I expand, p to the fifth is really p times p times p times p times p. Maybe you didn't know that. Let me know the part that you didn't know so I can understand your gaps and I can help bring you content that's just going to help the math and the algebra be made simple. So as always, like, subscribe, share, click that notification bell for more content and analysis. If you like what you heard, I'd love you to check out our resources. I work my own company called Morris Model Education. You can find the link in the description. Also, if you would like to have tutoring sessions or like to find out about our Algebra Made Simple special 10-week program that'll help your kid come alive, not be bored, be presented material in an interesting way that helps them run towards their future and not miss out on future educational opportunities, that can be found if you email me at morrismodeleducation@gmail.com. We'll have a free strategy session. I'll tell you all about it, and it will be of value for your kid for years to come, hopefully the rest of their life, the way I look at it. So anyway, let me know what you think on this one. I'll catch you on the next one. Peace.